All right, let's do this one. We're going to graph the system of linear inequalities. We have this first equation in standard form and the second one in slope-intercept form. That's going to be the easy one. So that's the one I'm going to start with. Okay, so let's get this one out of the way. I can see first that it has given me a y-intercept of 0, and that's going to be a -2 because of the minus sign. And this gives us a nice starting point. I'll put this one in red here on the y-axis of 0, -2. It also gives us the slope, which is why it's called slope-intercept form. So I now know that the slope is showing as -1/2. Now notice I've specifically given that negative to the 1 in the numerator. That's so that I know that my rise is going to be down, and then the denominator being positive is going to be to the right 2. So from that red point that we put onto the graph, I'm going to go down 1. There we go, down 1, and then to the right 2. And that gives me my next point. That also creates a bit of a stair step for me, which I can go again, down 1 to the right 2, down 1 to the right 2, and you can see the staircase is moving. Now, this is going from left to right. If I wanted to go from right to left, I would just simply reverse it, go left 2, up 1, which would give me the next point. And I do like to put all the stair steps that I can onto a graph, just so that I can see where the point should be. It also helps me to draw a better line, although sometimes it doesn't. In any case, I'm ready to put this in, and this line will be solid because it is also equal to the expression there. So we're gonna just put this line in straight as I can. That's actually not too bad for me, but it is definitely solid. The next one, we'll do in blue right here, and this one is going to be a dashed or dotted line. And that is because it does not have the equal sign as part of the inequality. So I'll try to make this dashed, maybe dotted. I'll just do the best that I can on that one. Now, most students like to look at this and change it into slope-intercept form, which I will now do. So, of course, the first thing that I need to do is zero out the x's. And I'm going to offset the -2x from the 1 because they're not like terms that I can combine. So I'm going to zero that out. I'm going to drop my negative. I'll show it as -1y is less than. Really, I don't care about the less than because I can just make it equal to. And then I'm going to switch the locations of the -2x and the +1. That's to make it look more like slope-intercept form. But now I need to divide both sides by -1. And the right side, since I have two terms, it just means that I need to divide all the terms by -1. Now, dividing by negative usually would flip that inequality, but again, I don't care about that because I'm looking for equality, which is where the line will be. So that's going to be a +2x minus 1. That gives me a y-intercept of 0, -1, which I can put on the graph right here. And it also gives me a slope that is 2. Now, the 2, I'm going to show it as 2/1. So that I can see the rise is positive, that's up 2, and then the run also being positive still will make this go to the right 1. So I'm going to go up 2 to the right 1 from the point that I just put on there. Up 2, 1, 2 to the right 1 gives me this stair step. And again, we're just going to duplicate that stair step, although my writing skills are not so great. Let's try going to the left again. But again, that'll be left 1, down 2. I'm just copying that stair step, right? Left 1, down 2, which gives me these points. Now to get my dotted or dashed line, I guess I'll go with dotted on here. This doesn't always look great, but I've done worse before. So I'm going to keep this something like this one right here, all right? Now I probably should have done this already, but getting the lines on first really isn't a bad idea. And, you know, if you wanted to, you could clean up these lines right here. But even if this was an exam, I wouldn't really worry about that. Let's start with the red line that we put on here. I need to know which side I need to shade on. So I need a little bit more space. So let's go and take care of that. And the red line, which was y is less than or equal to -1/2 x minus 2, right? I am going to test the point 0, 0 because neither of the two lines went through my test point, which is for me 0, 0. That's the origin, and the reason I use the origin is because 0 is such an easy number to work with. I can come back up here to the top left and replace the x and the y with the values that we've chosen from the origin. So that's 0, 0. And again, that makes things very easy to work with. That means that now I have 0 is less than or equal to, well, that would have been 0, 0 minus 2 is negative 2. 0 is less than or equal to negative 2, well, that is going to be false. Well, what does that mean? Well, that just means that I'm going to shade the other side of the red line. Now notice, I'm just putting these down just a little bit. I'm not actually extending these across the graph. That's because we still have to shade for the blue line. Well, what was the blue line's equation? The original equation, let's put that down, was 2x minus y is less than 1. And we have already found a test point for both lines, which is the origin. And so I'm going to use the x is 0, the y is 0, and this becomes a very easy calculation. It's 0 minus 0, 0. 0 is less than 1 is true. Now, since this is true, we have to shade towards that point from this blue, as bad as it is, dotted line. So I'm just going to put the shaded direction here. Now, where do they meet, or where do they both mix or crosshatch? It's this area right here, and that would be the area that I would want to demonstrate on the graph. Even if I was doing this by hand on an exam, I would just want to know, or let whoever's correcting it know, okay, I put the shading here in this one. I don't need to erase this. You don't need to erase it. Because, again, over here I've emphasized, oh, this is definitely where the two collide. This is where they overlap, they crosshatch, whatever you want to say. This is definitely the area that holds and contains all of the solutions to the system of inequalities. But that's it. That's all we got to do for this one. I hope that helps.